Decision errors. Decision errors can occur when choosing to reject or failing to reject the null hypothesis. There's two types of decision errors, type 1 and type 2. A type 1 error occurs when you reject the null hypothesis when in fact it was true. This error would correspond to taking action when you would have been better off not doing so. A type 2 error happens when the null hypothesis is accepted, in other words, we failed to reject, when in fact the alternate hypothesis is true. A type 2 error would correspond to taking no action when you would have been better off taking action. The power of a test against an alternative hypothesis is the probability that a fixed level alpha significance test will reject the null hypothesis when that particular alternative is true. The following table can help us identify our types of errors. So, if our null is true but we reject it, that's a type 1. When our null is true and we fail to reject, that's a correct decision. When our alternative is true, in other words, our null is false, and we reject, we've made a good decision. When our alternative is true and we fail to reject, we've made a type 2 error. So if we can organize our information from our problem in this chart, it can help us identify the type 1 and type 2 error more easily. Let's look at an example. You are considering whether or not to play your lottery tickets with your favorite numbers, so you have a chosen set of numbers. What situations denote the type 1 and type 2 errors? So let's say that our H naught is that we're not going to win the lottery. There's a very small chance that we would anyway. If we reject the null hypothesis, assuming ourselves that we would win and buy a ticket anyway, and our null is true that we won't win, then we've committed a type 1 error. And in that case, we bought a ticket and we didn't win. We're out the price of the error. Of the ticket, sorry. Both of these decisions would be correct. Our type 2 error would occur in this box. When our alternative is true, we would have won, but we failed to reject the null hypothesis. We thought we wouldn't win. So in other words, we would have won, but didn't buy a ticket. So you would be very sad if you watched those numbers come up on the screen when they were calling out which lottery numbers won. Now the probabilities of type 1 and type 2 errors can be calculated the following way. The probability of the type 1 error is the significance of the test, or alpha. If we're not given alpha, we can still calculate the probability of a type 1 error, but we need to remember some of our probability rules. The power of a test against an alternative hypothesis is the probability that a fixed level of significance will reject the null hypothesis when that particular alternative is true. The power is the complement of the probability of the type 1 error. An example. A manufacturer of circuits has observed that on average, 3% of its circuits fail. One of the engineers suggests changes in the design to improve this percentage. They find 100 circuits that will be made using this new method. The company will adopt a method if only 0 or 1 of the circuits fail in this instance. So let's identify the null and alternative hypothesis for this situation and talk about our possible type 1 and type 2 errors that the company might make. Our null is that our proportion is what it's claimed to be, which is 3%. Our alternate is that it's fewer. So we'll adopt the new method if we have less than that. So our type 1 error would be that we decide to adopt the new method. In other words, we agree with the alternate hypothesis here when the null was actually true. Our type 2 error is when we fail to reject H naught when we should have. So here, rejecting our H naught would mean that we're going with the less than and adopting the new method. So we would fail to adopt our new method. When we should have. So if the actual value for the new method comes out to be 0.01, what's the probability the company will make a type 2 error? Well, up here we say we're going to adopt the method if only 0 or 1 of the circuits failed. So remember, we're going to do the complement of that, which would be the probability that we had more than one fail, or rather 1 minus the probability that we had 0 or 1. Now we're going to use the probability of 0.01 in this calculation, and we're going to do just regular probability methods here. The probability that x is 0 with a p of 0.01 would be, we have 100 circuits, so 100. We're choosing 0 for x equals 0. Our probability of success to the 0, our probability of failure to the 100. And then for x equals 1, we have 100, choose 1, 0.01 to the 1, 0.99 to the 99. And this comes out to be approximately 0.264. So that's the probability of our type 2 error. So we stand above a 25% chance of making a type 2 error if our actual value for the new method is 0.01.